Hi Chris, thanks for your question. Today we're going to be finding the angle between two vectors, u and v. And to do that, we're going to be using our dot product. And our dot product tells us that u dot v is equal to the magnitude of u times the magnitude of v times cosine theta. It's important to note here that when we're using our dot product to identify what theta is going to be between 0 and 180 degrees. So when we find theta is either going to be in the first quadrant or the second quadrant. These bottom quadrants are now off limits. So let's go ahead and work on all of our unknowns in these equations and see what we can fill in. U dot v is just calculated component-wise, so I'm going to multiply the first component of u times the first component of v, add that to the second component of u times the second component of v. The magnitude of u is the square root of the first component of u squared plus the second component of u squared, so 4 squared plus 4 squared. The magnitude of v is calculated the same way, and that gets multiplied by cosine theta, because I have no way to solve for theta at this point. Simplifying this all down, I get 8 is equal to the square root of 32 times 2 cosine theta. Since I'm looking for theta eventually, I'm going to solve for cosine theta here. So I get 8 over 2 rad 32 is equal to cosine theta. And simplifying that, I get 1 over 2 rad 2 is equal to cosine theta. I can rationalize my denominator here so that if I multiply both the top and the bottom by rad 2, I end up with rad 2 over 2. That's all equal to cosine theta. Once I have solved for cosine theta, I have one of two ways to solve for theta. If I recognize it as a trig function that I can solve for immediately, if it's one of the 3 basic angles that I learned in trig class, I can do it that way. If not, I'm going to have to use an inverse trig function. In this case, I'm in luck. If cosine theta is equal to rad 2 over 2, I actually recognize that this is one of the 3 basic angles I learned in trig class. And I know here that theta is equal to pi over 4 or 45 degrees. And that will be your final answer. So it looks like in this case, I've got a theta that's in my first quadrant. I hope this has been helpful for you. Thank you for using SnapMath.